Dear friends, good day. The second topic of today's discussion is coal to electricity. Here we will learn how electricity is being generated, starting from transportation of coal, then its processing, combustion of coal, and how the energy liberated from the combustion of coal is transferred to water to generate steam, and this steam finally passes through steam turbine, that is also known as prime mover, and rotates an electrical generator, and in this way electricity is produced. In this lecture we will see an overview of the process. However, the detailing of various processes and components will be done in subsequent classes. Energy sources used for power generation are broadly classified into two categories. One is renewable energy sources and second one is non-renewable energy sources. Non-renewable or conventional sources of power generation includes coal, oil, gas, etc. The solar, wind, hydropower, specifically small, mini and micro hydro power plants, excluding large hydropower plants having a capacity of more than 25 megawatt, comes under renewable energy category. The geothermal biomass sources also are the part of renewable energy sources. The non-renewable energy comes from sources that will run out or will not be replenished for thousands or even millions of years. Most sources of non-renewable energy are fossil-based fuels. The definition of renewable energy is that energy produced from sources that do not deplete or can be replenished within a human's lifetime and have minimal adverse impact over environment. This is a very important thing, that the renewable energy sources are those sources which are having minimum adverse effect over the environment. From above definition of renewable energy, you can easily understand why the large hydropower plants are not treated as renewable energy power generation, as the large hydropower plants requires dam, which in turn create a large catchment area. Due to that catchment area, due to submergence, a lot of loss of vegetation takes place, which if might have existed, it must have absorbed the harmful gases, and in turn indirectly it is affecting the environment along with the other socio-economic issues as flooding of fertile land, migration of population, etc. The non-renewable energy or fossil fuel-based power plants produces harmful gases as carbon dioxide, carbon monoxide, SOx and NOx. Already in previous class on Indian power scenario, you have gone in detail of the power generation status in India. So here we will have a quick overview. It is very much clear that the majority of electricity in India is produced by coal, which contributes more than 50% of the total power generation. Other sources includes large hydropower plants, which is the part of conventional power generation, which contributes nearly 12% of the total power generation or total installed capacity. Then comes nuclear power plants, which contributes only 1.83%. Then gas, which contributes almost 6%. Then diesel, which is not generally used, only the places where the grid is not available. So small gensets are used for power generation, as the diesel being a very costly fuel, so it is not economical to use it for longer duration. The present total power generation is 370 gigawatts, and this data is based on the information available as on April 2020. Now here we can see the energy map. You can see from this, the northeast and upper part of northern region, they are blessed with hydro potentials. Coal reserves are mainly in eastern region. The distribution of energy resources and load centers are extremely unbalanced. It means the power plant, which is spread over throughout the India, some of them are very far from the resource, that is coal, due to which it requires power transfer over long distance. All power generation units, whether it is a thermal or hydro or wind or gas based power plant, has prime mover, which is known as turbine. In a thermal power station, the prime mover is steam driven, water is heated, turns into steam, and it spins a steam turbine, which either drives an electrical generator or does some other work like ship propulsion. The steam, when passes through the turbine, the steam gets condensed in a condenser and recycled, because the steam is produced with DM water, which is very costly in nature, and we can't afford to just waste it. There are variations in the design of thermal power stations due to the different fuel sources like coal, natural gas, diesel, nuclear, solar, thermal, etc. Thermal power plants can deploy a wide range of technologies. Some of the major technologies includes steam-based power plants, where motive forces to rotate prime mover or turbine comes due to the expansion of steam, while in gas turbines, the compressed high temperature gas is used to move turbine. The cogeneration plants and combined cycle plants, it is very important to understand the difference between this cogeneration and combined cycle power plants. The cogeneration plants are those plants where main aim is to produce process heat, and power generation is secondary, as sugar industry, cotton industry, injection molding based factories, etc. A combined cycle power plant uses both a gas and a steam turbine together to produce up to 50% more electricity from the same fuel than a traditional simple cycle plant. The waste heat from the gas turbine is routed to the nearby waste heat recovery boiler to generate steam, and operate a steam turbine which generates extra power. Internal combustion engines are also, we can say, is a type of thermal power plant which is commonly used for small remote sites or standby power generation, like diesel engine or diesel gensets, where the motive force comes because of the combustion of the diesel fuel, which rotates the diesel engine, and the connected electrical generator is also rotated, and finally electricity is produced. Now, as our focus is basically on how electricity we can produce from coal and why we are selecting coal as a fuel. So there are certain advantages of coal fuel in comparison of other fossil fuels. That is, coal is abundantly available in India, its cost is low, and already we are having well developed power generation technology which is coal based, and it is easier to handle, transport, store and use. But with these advantages, definitely coal is having some shortcomings. The first thing is that its low calorific value. Also, the calorific value varies from coal to coal depending upon from which mine that coal comes. Large quantity is required. It produces pollutants as carbon dioxide, carbon monoxide, SOx, NOx. Ash is also formed, that is also a nuisance. Then this huge amount of ash which is being generated because of the combustion of coal, its disposal is a problem, and coal is a fastly depleting source of energy. Coal is produced from surface mines and underground mines. Certain properties which coal exhibit is calorific value. Grade of coal is based on GCV, that is gross calorific value, and sometimes it is based on UHV, that is useful heat value. Proximate analysis gives coal composition in form of moisture, volatile material, ash and fixed carbon. The ultimate analysis gives chemical composition in form of carbon, hydrogen, oxygen, nitrogen and sulfur content in the coal. It is mainly that carbon which combusts, and the combustion of carbon is an exothermic reaction. During the combustion of carbon, the heat is released, and this heat is utilized to generate the steam. This grindability index is to show with how much is coal can be pulverized. There are some certain physical characteristics of the coal, that is hardness, color, weight and volume. This slide shows the general layout of thermal power plant and also exhibit main equipments and their respective arrangements. Some of the main components are boiler, turbine, generator, condenser, cooling tower, then CW pump, then economizer, air preheater, electrostatic precipitator, chimney, etc. Coal is transported from mines, then it is pulverized to a size of 75 micron, which is like the fineness of a talcum powder. Because of this pulverization, the surface area increases and simultaneously its fluidity and flowability also increases, which makes and due to its fineness during combustion, coal makes homogeneous mixture with air, which leads to the complete combustion. Due to combustion of coal, heat is liberated, as the coal combustion process is an exothermic reaction, and the heat generated is used to generate superheated steam. This steam passes through turbine, which applies mechanical force to rotate it, in turn to rotate the generator, and finally electricity is produced. So in this process, the chemical energy of coal is converted into thermal energy or heat energy, and this heat energy in turbine converts into kinetic energy, and this kinetic energy of turbine is finally converted into electrical energy through the generator. In this process, when coal is combusted, during combustions, there some heat loss takes place. Ash is formed, which is not desired, and during this combustion, some pollutants are also liberated. So the generated also the heat which is produced finally goes to heat the water and generate steam, and this steam basically goes to rotate turbine and generator. As being this is a closed cycle, the steam which is generated after expansion comes to the condenser, where it loses its heat. That is also a loss. Depending upon the efficiency of turbine, there will be mechanical energy loss in turbine. Similarly, depending upon the efficiency of generator, there will be certain electrical energy loss. So this is the total basic of the process, how the chemical energy of coal is finally converted into electrical energy. We will see the basic operations that takes in thermal power plant. Coal, which is our fuel, is combusted and used to boil the water. This boiling water converts into high temperature and high pressure steam. This high pressure steam applies the force over the turbine and rotates it at high speed. After passing through this turbine, the pressure of steam gets reduced. So this low pressure steam coming out from the turbine is sent to the condenser, and condenser is a place where the steam is converted and bring back to the liquid form, and again this process is repeated. Now we will see the main equipments that is used in thermal power plant for the power generation, starting from the coal handling plant, then coal pulverizing unit, then boiler, then turbine, condenser, then cooling towers and ponds, feed water heaters, economizers, and air preheaters. The details of these components will be discussed in subsequent classes. However, Here we will see in brief the functioning of each equipment. Coal handling plant. Here coal is transported to power station by rail or road and is stored in coal storage, and then from here it is sent to the pulverizer unit. The function of coal handling plant is automatic feeding of coal to the boiler furnace. A thermal power plant requires huge amount of coal. As a thumb rule, a typical 200 megawatt thermal power plant requires around 200 tons of coal daily. The consumption of coal depends upon other parameters too, that is quality of coal, then property of coal, and the combustion efficiency. As we had seen in earlier discussion in previous slide, that huge amount of coal per day is required, and this coal is transported through train which have coal rakes, and each rakes have number of wagons, and in general one rake consists of 60 wagons and each wagon weighs 60 tons of coal. It is not feasible to unload the coal manually as it will consume much time. So to unload coal, the wagon tippler is used. It is just like a turntable. Coal wagon comes with shunting engine and is clutched with the help of clutcher, and the wagon with the help of wagon tippler is turned almost 120 degree, and in this way a wagon is emptied in very short time. A video showing the working of wagon tippler is given in next slide. Here you can see how the shunting engine is bringing the wagon and wagon tippler unload the coal filled wagon. coal unloaded through wagon tippler falls on conveyor belts through grates which prevent uh, of falling the big size of coal on conveyor belt. The coal is transported through network of conveyor belts up to the pulverizers through raw coal bunker, the detail of which is exhibited in next slide. The coal which is received generally varies in size. So after unloading it through conveyor belts, it comes to the primary crushing unit where the coal is crushed in a size of 125 mm. This 125 mm coal is finally sent to the secondary crusher where its size becomes 25 mm, and this 25 mm coal is being transported through conveyor belts to the main plant or to the milling plant where it is stored in the raw coal bunker. From this raw coal bunker through feeders, the coal goes to the pulverizers. In this slide, we will see the different equipments used in coal handling plant. This is basically about crushers, double roll crushers, impact crushers, vibrating screens, conveyor belts, magnetic separator to remove if any iron content comes with the coal, then vibro feeders. Double roll crusher, the construction is like this. The coal falls in between these two teeth, which is rotated, and in turn coal get crushed. This figure shows the impact crusher, which acts like a hammer and crushes the coal. This is vibrating screen. It is used to separate coal in different sizes by giving it vibratory motion. There are various protection devices used in coal handling plant, and mainly they are zero speed switch, pull card, and belt sway switch. Zero speed switch is used to detect jamming or slow speeding of motor shaft, and thereby it stops the motor automatically. When it senses if there is any jamming or there is speed reduction of the motor, it automatically stops the motor. The pull card switch is also known as rope operated emergency switch, is used as a safety switch to stop the conveyor belt in case of an emergency. Belt sway switch is a protective switch for detecting the mindering of belt conveyors and sends out an alarm signal and an emergency stop signal, suited to be used for belt breakage prevention when running out of center and overfeed prevention due to the belt sway. Basically, it safeguards the conveyor belt from breakage. Then there is an emergency switch which is used to be present in the field, and one can operate it if there is